It's also important to go the other way around. What I want you to do now is see if you can draw the tree from the following constructor. So take a moment to do that. I'm going to spoil the answer in 3, 2, 1. So I'm going to, again, use this pen. That's so awesome. So where is that? Pen. There we go. Okay. So, again, I'm going to start step by step. We have at first, we obviously have a root value 1. So there's our root. And then, how many branches do we have here? So notice that branches start basically from here. Okay? So now we have to figure out how many elements of the list we have. Well, we have one right there. We have another right there. And we have another big one right there. So this is the key thing to notice. Okay, so, well, the first one's pretty easy. So this just means, so basically what this means is I have 3 branches. So I'm going to draw my 3 branches. And the first one is pretty easy because it's just a leaf. So bam, I'm done there. So this is done. Okay, now let's move on to the next one. Okay, so this one's a little more tricky. We have a tree that has an entry of 3. Okay, so I can put an entry of 3. But now this has 1 branch. Okay, so I'll draw 1 branch on that. And what's that? Oh, that's a leaf. That's easy. Great. Now I'm going to go, so I finished this one. And now I'm going to go to the next one. So, okay, this seems a little complicated, but we'll use the same idea. So we have a tree that has the entry of 5. Awesome. And then how many branches does this have? Well, this has 1, 2, 3 branches. Okay, so now I make my 3 branches. And so what's the first element? Tree of 6. Oh, that's a leaf. Great. Second element is a leaf. Great. Third element is a leaf. So see how you can see this initially looked really complicated, but once we deconstruct it and really ask ourselves the important questions of what's the root, what's the branches that, how many branches do I have, what's the entries of those branches, we can basically get down to the bottom of this, and it's really not that bad. So I don't want you to get intimidated by trees. And if you really understand how to represent trees, both from a constructor to a diagram and a diagram to a constructor, tree processing questions are going to be much easier. So that's how we do that. So let me get rid of that pen. And now we're just going to work on tree processing. And what we mean by tree processing, working with problems that relate to trees. And working with trees actually relies heavily on recursion, because at the end of the day, it's the fact that every single branch of a tree is also a tree. So we can use that to our advantage, because every branch is a simpler problem of the entire tree itself. So recursion is a natural way to handle that. And actually, all the problems today are going to be recursive, except for a few easy ones. So let's look at some tree problems. Okay. So here, what we have is a pretty simple function where we're basically going to find the root of a tree. Any tree that we pass it in, we want the root. So here, we have the root. So obviously the root of this tree is just 1. Bam, we're done. We want to get, okay, so now notice that this is going into the first branch of my tree. So what's the first branch? It's this thing right here. And what's the root of that? 2. And then this one goes into just finding the root of this, which is 1. So this may seem like a little bit of a trick question, but it really is actually pretty easy. So it's just actually just return t.entry. Because whenever we have a tree, how do we get the value associated with that as its root? We go to the entry. So that's all this is. So don't feel like this one was harder than it seemed. This is meant to be an easy problem. Okay. The next question we're going to have is another decently simple problem. We're going to ask ourselves, how do we know if a tree is a leaf? So we have to ask ourselves, what's the definition of a leaf? So if we remember from before, the definition of a leaf, let's go up to this slide right here. So a definition of a leaf is a tree with no branches. So what does it mean to have no branches? So that's what we have to think about. Let me go back to where I was. Okay, so to have no branches means that basically this list has to be empty. So our branches has to be empty. So how can we check that? It's just a matter of doing return t.branches. And we want to make sure that it's an empty list. So one way we can do that is just find the length of that and make sure it's 0. So return length of t.branches is equal to 0. So let's make sure that works. Oh, I probably should have tested the other function too. So yeah, let's test both of them at once. And it works. Okay, so both of these functions work. And I was pretty confident about both of these because they're fairly simple. Now we're going to go into some more challenging problems. So this is where we're really going to see the recursive definitions of trees come to great help in solving these types of problems. So we basically want to take any tree and we're going to return the sum of all the values in the tree. So how do we do that? And to help with this function, I'm going to show you a real quick, nice helper function you can use when working with lists. So let's say we have a list 1, 2, 3. How do we find the sum of this list very quickly? Well, we can actually just use the sum function. There's a built-in sum function that does it. And it turns out the sum of the empty list is also just 0. So that's pretty nice. So that's going to be useful in this function as well. So, well, again, with any type of tree problem, we're going to be most likely we're going to be working with recursion. And the simplest, when we're dealing with recursion, we want to work with the simplest possible case. So what's the simplest possible case of a tree? Well, generally, it's going to be the case where we just pass in a leaf, because that's just one element. So I like to usually use that as my simplest possible case. So if it's a case that my tree is a leaf, so we have a function now for that, well, what's the sum of that? It's just t.entry, because there's only one element in it, so that's the sum. Now, if this is not the case, we basically have to find the sum of the branches. And so we have to find a way to go through the branches and find the sum. But what do we know about the branches? They're trees. So what's the function that can help us find the sum of trees? Well, that's the sum function, sum tree function. So this is the key idea. Noticing that every single branch is a tree itself, we can use the simpler version of the problem to build up to a larger solution. So basically what I'm going to do is I'm going to define a branch's sum variable that's going to be equal to the sum of every single. So what I'm going to do is I'm going to call SumTree recursively on every branch for every branch in my in the list of branches of a tree. So how does this work? Well, what it's going to, so actually I'll talk about that later, but the final answer is that once we have the branch's sum, it's just a matter of taking the entry and adding it to the branch's sum. So here the branch's sum should be 5, and then once I have that, it's just 1 plus 5. Here the branch's sum should be 20. Once I have that, it's just 1 plus 20. So return t.entry plus branch's sum. And once I have that, let's just test this. And it works. So let me go a little into how the recursion of this works, because this can be a little hard to see. But basically what we're going to do is, if we have a tree like this that has branches, so I'm just going to work with this example because it's fairly simple and easy to see. So what we're going to do is we're going to go through, so this entire tree is obviously not a leaf, so we're going to go into this, and so now we're going to call SumTree on every branch. So what are the branches that we get? Well, we have two main branches. We have one branch here, which is a tree, and we have another branch here. Okay, so once we know that, well, what we can do is realize that finding the sum of this branch is just a matter of passing it back into the function, because this is a leaf now. So if we pass it back into the function, we'll get the t.entry of that. So that's 2. So one element of this list that we created using this list comprehension is going to be 2. And the other element of that is going to be the next branch, which is 3. So now this list is going to be built up of the elements 2 and 3. And we just take the sum of that, and then we add the t.entry of that, and we get our final answer. So that's kind of how the recursion works on this. And the list comprehensions are very useful for trees because basically we're going to be going through every single branch. And a very concise way to do operations on that is using a list comprehension.